Okay, so today we'll be talking about our part number 2 of our Hammett equation. So as we start in the last class, Hammett started with a benzoic acid, because benzoic acid is a weak acid, so you can study. आप study कर सकते हैं effect of substituent on this. If it's a strong acid, then you can't do that because the acid is already strong. And then हमने ये भी discuss किया था that the substituents at the meta and the para position. ठीक? Because whatever substituent is at the ortho position, acid will always be a stronger. That's called ortho effect. So that we will not discuss. So this arrow means I am putting the substituent at meta and the para positions. This carboxylic acid dissociates to give the carboxylate ion, which is called the conjugate base of the acid, plus H positive. You can represent it in the form of hydronium ion because water accepts that. ठीक है? So now फिर मैंने क्या किया यहाँ पे, I am writing down Kx, rate constant of this reaction or dissociation constant of this carboxylic acid which has any substituent at meta para position, that is directly proportional to the stability of conjugate base. अगर आपका conjugate base strong, stable है, obviously the equilibrium will move in the forward direction. That means more and more carboxylic acid will get dissociated. ठीक है? ठीक है? Now, so let us say now we have electron withdrawing groups here in the ring. So I will write down electron withdrawing, WG, EWG. And if there are electron donating groups, so we'll designate by electron donating groups. So we have two types of groups in the ring. ठीक है? Now, so what will happen? If you put electron withdrawing groups here, so that means you have electron withdrawing group here. So what that will do is that will disperse this charge across this ring. Electron withdrawing groups will pull the electrons. ठीक? So what will happen, that this negative charge will get dispersed. So if negative charge gets dispersed, the conjugate base becomes stronger. If conjugate base is stronger, that means the acidity of this increases, or we should say this dissociation constant increases. So we can write down that the dissociation constant, it's directly proportional to the strength of electron withdrawing group. Electron withdrawing group जितना strong होगा, for example, if it is nitro group, that is highly strong than your, let's say, a carbonyl type group. Likely if you have cyanide group. So if you have more electron withdrawing group, then accordingly this value will come more. So that because this negative charge will get more dispersed. So conjugate base stabilizes, the acidic strength increases. Likely this dissociation constant or ionization constant, we can write it inversely proportional to the electron donating groups. If you have electron donating groups, so they will try to increase this negative charge rather than minimizing this negative charge. ठीक? So electron withdrawing groups will increase the acidity. Electron donating groups, the strength, जितना ज़्यादा electron donating group ज़्यादा strong होगा, this value will decrease. So carboxylic acid will become weaker and weaker. Now this is the basics. Now कोई भी chemical reaction जो होती है, we know that to understand that there is energy level diagram. Let's go to the energy level diagram. Let me draw the energy level diagram. ये बहुत important portion है इसको understand करने के लिए. Energy level diagram. Let's write down the energy level diagram of this carboxylic acid molecule. Let me write here. Energy level diagram. So we have two axes here. This is your y-axis. Let's say it represents the free energy change during the course of reaction. This is your axis that represents the reaction coordinate. A reaction coordinate. A reaction coordinate, we know it tells us the progress of the reaction. Progress of reaction. ठीक है? Now कोई भी chemical reaction हो, let us say the dissociation of this, we have the reactant side here. So we know that the product will be having less energy. Reaction तभी होती है जब आपका reactant जो है it gets converted into the product has less energy than your this reactant. So we'll write down it something like this. So this is in general what the diagram looks like for different types of chemical reactions. So this is your product side. So product side means this is your benzoic acid. Let me show it. This is benzoic acid dissociated. So this ring actually represented by phi. ठीक है, यहाँ पे I will show benzoic acid like this. This is benzoic acid. So that's your some sort of reactant. This is your product side. So that means to get dissociated, we need this much amount of activation energy. So first, this carboxylic acid molecule needs the energy. So this is your transition state, this point. And then once, and at the transition state, we know that the molecule is position में होता है कि old bonds will get, they are in a position to get broken down, they are partially broken, and the new bonds start forming. जो chemical reaction में होता है. तो यहाँ पे this is the transition state of the molecule. So this is how you need this much amount of energy. You say it's an activation energy. And then finally it gets converted to your product, which is your dissociated carboxylic acid molecule. Now rate of reaction जो है ये बहुत important. ये किस पे डिपेंड करता है? एक चीज, it depends on this activation energy. सीधी सी बात है, if the activation energy is less, let's say that if the activation energy is less, something like this. This is one pathway. If activation energy बहुत कम हो गई, यहां से नीचे आ गई, the reaction will occur faster. So this dissociation will occur quickly. So it depends on this energy barrier. अब ये जो energy barrier है, how can you modulate this energy barrier? This is something interesting जो हम research में करते हैं. How can you modulate that? How can you increase the energy of this barrier? How can you decrease? How can you reduce the energy of the barrier? That will determine the rate of the reaction, whether reaction occurs fast or it occurs slowly. That will also tell us whether the acid is stronger or acid is weaker. If the reaction occurs faster, the acid is stronger. That has an indication, that it puts an indication in our mind that this energy barrier has gone down less. That means जो आप electron substituent यहाँ put करते हो, what actually ultimately they do, they try to manipulate this. They try to modulate this energy barrier. They try to manipulate this reaction, the activation energy. Or in other words, they have something to do with the transition state. What they do, they play with the transition state. तो इसलिए हम क्या करते हैं, when we do the research, we put different substituents and then try to see the effect of those different substituents at para and meta position. Then what actually internally हम क्या कर रहे होते हैं, we are trying to change this transition state, modulate the transition state. Transition state क्या होता है किसी भी chemical reaction में? Let's remember, this transition state is either charged, it's usually charged. If it is charged, we have to see it is negatively charged, or it can be positively charged. Transition state, we know it is less stable. वहां पे क्या होती है, bonds partially broken down and new bonds partially started forming. So ये एक ऐसा state होता है, it is either positively charged either negatively charged. Number one point. ठीक. And then transition state has, this is point number one, the transition state is charged, it's positively or negatively. Second, we have the energy barrier. वो transition state reactant से कितना ऊपर है? So we have the term called energy barrier or activation energy. Now ये दो चीजें हैं which will be manipulating, will be tuning by the different substituents in this ring. So that will determine us, that will tell us the rate of the reaction, or that will tell us actually how the strength of acid will increase or decrease. ठीक है? Now let's talk about point number one. If this transition state gets stabilized, क्या मतलब? For example, if it is negatively charged, आपको कोई ऐसा सबस्टिट्यूट इसमें डालना है कि that will try to minimize the negative charge. Number one. ठीक है? Likely if it is positive charges, we should have a substituent that will minimize the positive charge. ठीक है? Now सीधी सी बात है, if this is positively charged, I will put a group that is electron donating. Let's say I will put a group that is electron donating. उससे ये positive charge खत्म हो जाएगा. Number one. If the transition state is negatively charged, I will put a group that will be electron donating. Sorry, electron withdrawing. Withdrawing से क्या होता है? It will remove the negative charge density. It will bring this towards the neutral state. सो हमें चार्ज को खत्म करना है. दैट मीन्स अगर ट्रांजिशन स्टेट पॉजिटिवली चार्जड है, सो इलेक्ट्रॉन डोनेटिंग ग्रुप्स will stabilize it. जब ये stable आएगा, that means the energy comes down, the energy barrier becomes less. Likely if this is negative charged, then electron withdrawing substituent will minimize the charge because they will disperse this charge in the ring. ठीक है? But in this case we know it's negatively charged. This is point number 1. So now looking at all this, so if you have, that means electron, अगर हम electron donating withdrawing groups की बात करेंगे, electron withdrawing groups, since what they will do, they will try to disperse this negative charge, so I should say they stabilize the transition state. They stabilize the transition state. Stabilize matlab it will come down, the energy will go down. When energy will go down, let's say it follows this path, so rate of reaction becomes faster. So that means we should say the rate of reaction is more. This is point number 1. Likely, since we have a negative charge in the transition state here, so if we put electron donating groups in this case, so what they will do, सीधी सी बात है, वो instead of dispersing this negative charge, they will increase the negative charge because they will push the electron density toward the ring. So that means it will become destabilized. Now it can follow this path. इसमें हमारा उल्टा हो सकता है कि the energy will increase rather than it will decrease. You see it is increasing because this negative charge is becoming more and more intense by the electron donating substituents. So electron donating groups, they will destabilize the transition state. इसका मतलब ये है the rate of reaction decreases. That in turn means dissociation will decrease, the strong capacity will decrease. I hope up to this point we are clear. Now, so I would write down, so let's say we'll put now the rate constant. Instead of this, let's write down the rate constants. So we'll write the rate constants like one second, there's some issue with this. So we'll write down the rate constants like, okay, so let me put it in this way. So we'll write the rate constant for electron donating groups, sorry, withdrawing groups, Ka, dissociation constant for electron withdrawing groups. ठीक है? So this is this, and for donating groups, rate constant for electron donating groups. ठीक है? So rate of reaction in this case क्या होगा? So the rate of reaction, so this rate constant will be more than simple. जो हमने अभी डिस्कस किया, because they stabilize the transition state, they disperse the charge. So rate constant for withdrawing groups is greater than for the donating groups. Our dissociation constant for withdrawing, in presence of withdrawing groups and substituents, that is greater than donating substituents. ठीक है? और इस तरह से हमने पहले क्लास में भी इसको डिस्कस किया. If we don't have any substituent, then the rate constant is Kh. So we have three types of rate constants: Ka in presence of electron withdrawing groups, Ka in presence of donating, and Kh. Now अगर हम तीनों को कंपेयर करें, then we'll say a rate constant in presence of electron withdrawing groups is followed by rate constant in absence of any group, because there is no group, so obviously it is the transition state is more stable than this. Then a rate constant in presence of electron donating groups. So this is the order. Benzoic acid, where we have the meta and para substituents which are electron withdrawing, that is stronger than unsubstituted benzoic acid, stronger than, followed by the substituent. This is our question. Now we'll do something like this. Let us make a ratio: rate constant in presence of electron withdrawing groups divided by Kh. That means the dissociation of benzoic acid divided by the dissociation of, So benzoic acid with electron withdrawing substituent, and then in the absence. So it's obviously greater than 1. See, because we expect it will be more, because electron withdrawing groups, they stabilize the transition state, so the rate of reaction followed this path. The reaction follows this path. Or the dissociation of benzoic acid follows this path. So the rate of reaction is more, it's greater than 1. So the value comes greater than 1. Likely I will write down the dissociation constant or rate constant in presence of electron donating groups divided by KH. So that will be less than 1. Because donating groups destabilize the transition state, they decrease the rate of reaction. They destabilize the transition state, they increase the activation energy. So obviously the ratio is less than 1. Now ये बहुत important चीज़ है, let's keep it here. Now third point, if you want to write this in the log form, let's now convert this into the log form. So we'll get log of Ka in presence of electron withdrawing divided by, it's like this, Kh. So when we do the log of 1, that is log of 1 is 0, log of greater than 1, so that will be plus. I'll write like this. Without writing the value, I will put plus, because log of 1 is 0, greater than 1, anything greater than 1, that will come plus. Likely if we want to write here, so it will become log of Ka by electron donating by Kh. Log of 1 is 0, less than 1, so that will become negative. Now ये बहुत important term है, that this value is negative, and so this is plus, and for donating groups it's negative. इसका मतलब ये है that if we have the data available for this ratio, the ratio of these rate constant or ratio of these dissociation constant, वहाँ से जो हमें value मिलेगा plus or minus, now that value will give us idea about which type of group is present in the ring, whether it is electron donating group, whether it is electron withdrawing group. That's number one. Now this is the beauty of the Hammett equation. Now this data, by knowing this data, this dissociation constant of benzoic acid in absence of any group and in the presence of electron withdrawing and donating groups, we can know this value, number one. Now if you know the value, so that means the first point will know value by knowing, so by knowing this value, this ratio, so what is the output we'll get? Number one, it will give you an idea that whether in that ring you have electron donating or withdrawing groups, number one. So we'll come to know by this data electron donating or withdrawing groups in the ring, number one. Number two, if this value, if plus value is high, if the value of plus is, for example, is plus 2, plus 3, plus 4, plus 5 accordingly, likely if the minus value is minus 1, minus 2, minus 3, so depending on what is the numerical value, that value will tell us the extent of strength of that particular group, कि वो group कितना electron donating और कितना electron withdrawing strong है. So this value can also tell us the nature of the groups, nature of electron donating or electron withdrawing groups. That means I will come to the conclusion. So this data of this ratio of dissociation constant or reaction rate of reaction of this dissociation of benzoic acid, it will give me quantitatively the nature of, I can predict quantitatively, not only qualitatively, the nature of electron donating or electron withdrawing groups, or I should say the power, the electron donating or electron withdrawing power of various groups. So I will sum up this for the today. So I can predict with the help of this data I can predict qualitatively as well as quantitatively, that means which type of group, and I can predict quantitatively, that means the strength of the groups, the nature of groups, or the electron donating or electron withdrawing power of groups, power of substituents in the ring or in the benzoic acid. So by knowing this ratio, so the Hammett equation, with the help of this Hammett equation, all this data, So this will calculate from different means. We know that we can calculate the dissociation constant from different types of approaches. So that will help us, this ratio, that can help us qualitatively as well as quantitatively, the power of electron donating and electron withdrawing groups, electron withdrawing substituents in the benzene ring. So now this is one of the important points that we should always keep in the mind. और दूसरा चीज हमें ये भी पता चलेगा, this ratio can also tell us that whether your transition state was positive or negative. In this case, since we know, लेकिन sometimes जब reaction होती है unknown, we don't know the कि कैसा बनता है वहाँ पे. यहाँ पे we know it's very simple, it should be negative. But while the reactions are unknown, we don't have idea about the nature of the transition state. It is positively and it's negatively. वहाँ पे भी will come to know this ratio with the help of this data. We'll come to know that whether the electron donating groups increase the strength of the acid or electron withdrawing groups increase the strength of the acid. ठीक है. So वहाँ पे भी we can predict the qualitatively and quantitatively the power of substituents present in the ring at ortho and meta position in for example in benzoic acid जो हमने यहाँ पे study किया है. So this is all about the basics behind the Hammett equation. Let me go back to that Hammett equation. This one. So this was X. यहाँ पे X को confusion होने की जरूरत नहीं. It means the presence of substituent in the ring, whether it's donating or withdrawing. And H means when you don't have any substituent in the ring. So rho हमने कल भी discuss किया. It gives me idea about the types of groups. It gives idea about the electronic effect. And rho gives me idea about the transition state or reaction constant. ये मैंने कल भी डिस्कस किया, reaction constant or transition state. Now ये तो आज का क्लास होगा. There's some few more points are there which I will not be discussing in today's class. Now that's why this equation is called as linear free energy relationship. So this equation is also called as linear free energy relationship. ठीक है. So how is that possible? And then how can we calculate this rho value? This rho value also we can calculate with the help of that linear free energy relationship, but that we'll see in the part number 3rd. That will be a basic class. So, but hopefully that will be in the couple of days. I will try to finish this. I hope the basics will be clear with you people. If still there are questions, so please write down to me back. Write down the comments, or you can put up a message also. So no issue. So this was all about the basics of the Hammett equation. And then inshallah in the next class we'll see that linear free energy relationship, why it's called linear free energy relationship, and how we will calculate the value of rho. Thank you.